I get norm squared. If I dot a vector with itself, I get norm squared. So that's alpha I norm s squared. What's the norm of s? 1. So this is equal to alpha I. So that's also interesting. So what happened is the match filter the noise-free output is the component in the S vector, in the basis vector direction. So that'll become important when I have multiple basis vectors. So what I'll have is multiple matched filters, each one doing the dot product with itself, with its own basis direction. And in the noise-free scenario, what I'm getting back are basically the coordinates of that point in signal space. So in other words, in one dimension, what I get is the one-dimensional coordinate, which is alpha I. In multiple dimensions, I will get the coordinates in each dimension. Okay, any questions on that? So I'm going to make a comment about energy per bit. Energy per symbol versus energy per bit. Okay, what's energy per symbol? Let's call it ES. That's the average energy that it takes to transmit one of my letters from 0 to n minus 1. So in binary a bit is a symbol. So in binary we had the energy per bit is equal to the energy per symbol, which is equal to the probability of sending a 0 times the energy in a 0 plus the probability of sending 1 times the energy in a 1. Now, energy per symbol, if I have more than 2 letters, I take the sum from I equals 0 to n minus 1. Probability of sending that symbol times the energy of that symbol. What is the energy in the ion symbol? Well, my modulation function is, my modulation vector now is S, SI, which is alpha times the basis vector. And if you remember how I did this in binary, basically what I did was I took every coordinate here and squared them. And then I multiplied by the sampling time. I multiplied by the sampling time because I'm trying to approximate a continuous value function by a series of rectangles that correspond to the coordinates of the samples. So if I take every point here and square it, basically what I'm doing is I'm taking norm squared. And then I multiply by TS. So energy, the energy in the I symbol is equal to the norm alpha S squared TS. If I have a constant multiplying a vector, it turns out that that will come out of the norm. And because I'm squaring the norm, I end up with, excuse me, that's alpha I. I squared, norm S squared ts. What's norm S squared? That's the basis sigma. 1. This is alpha I squared ts. So this is equal to the sum y equals 0 to m minus 1. Take ts out. Probability of I, alpha I squared. Energy per bit. How do we get that from energy per symbol? Any ideas?
Just divide by n.
Close. So basically, if you think about the units analysis, this is energy per symbol, and then I need to multiply by symbols per bit, which is equivalent to dividing by bits per symbol. How many bits per symbol? So we don't divide by m, we divide by what?
Log 2m.
Log 2m. So EB is ES divided by log 2m. So this is how you fairly compare. What you will do is for constant probability of error, this is how you will compare the energy expenditure between a binary scheme, actually between two M-ary schemes, for example. This is how you do that. And in general, it's much more expensive in energy to do M-ary over one dimension than it is to just do binary. But remember what I said when we started talking about M-ary. For instance, if you have 4-ary, it may cost you a lot more energy, but you're doubling the data rate. So M-ary is something that you do when you've got lots of energy, but not much time. So for example, let's have a couple examples. I will, let's do an example of calculating energy per bit. Let's start with an example of calculating probability of error. So let's have a 4-ary. What I'd like to do is I'd like to have S of the form similar to polar NRZ. I'd like to have it all constant up to NB. Now, my question for you, bearing in mind the properties of S, can this be equal to 1? What's the one property of S is the norm S is equal to 1. Can that happen? No. Basically what I need to do is I need to normalize S. So S is equal to, let's call the following S prime. S prime is equal to all 1 to NB. Like so. So S, basically I normalize S prime. So this is S prime divided by the norm of S prime. What's the norm of S prime? Well, I know that the norm of S prime squared is equal to S prime dot S prime. So therefore, S prime is equal to the square root of S prime dot S prime.